is that of plane stress and its elements. There are 3 independent stress, 2 normal stress, sigma x and sigma y, and 1 shear stress, del xy. To determine the stress transformation by using Mohr circle, the first step we must establish coordinate system. This horizontal line is described as plus x-axis. The vertical line is described as plus y-axis. Next is defining the stress. We must make sure that we can distinguish between the positive stress and negative stress based on coordinate system. Now look at here. To define the normal stress, we must notice whether the sigma x or sigma y lines are away or closer from the plane. If they are away from the plane, the value will be positive. But if they are closer to the plane, the value will be negative. And to define shear stress, we must notice that up and right directions have positive value, while down and left directions have negative value. Take a look at the arrow's directions. If both of x and y arrows are going into positive direction, the value of the shear stress will be positive. But when the arrow's sway is into negative direction, the value should be negative. Take a look into this plane. These arrows indicate the positive shear stress. Why? Because the way of x and y line are into positive directions, and because positive plus positive is positive. Now, let's try to find the stress transformation by using Mohr circle for this case. To make Mohr circle, first we must establish the coordinate system. Make a scale for the coordinate system. In here, the scale will be 1 cm equal with 100 MPa. Next, we must determine C coordinate. C coordinate is 0 and sigma average. Afterwards, determine the reference point, A coordinate. This point represents the normal and shear stress components. Now, connect point A and point C. Next, to find new state of stress associated with new orientation, we need to rotate this line by angle 2 theta for Mohr circle with orientation 30 degree clockwise. Once R has been determined, sketch the circle. Yeah, this is a Mohr circle. By this circle, we could define the value of normal stress x-axis, normal stress y-axis, and shear stress xy-axis. To determine normal stress x-axis, pull the line from C coordinate to the outer circle groove arc line, and we could see its value by seeing the axis. Based on the axis, the value of normal x-axis is 550 MPa. And to determine normal stress y-axis, pull the straight line from normal x-axis point to the outer circle. Mark the point and pull the parallel line from sigma x-axis point as far the point marked. Based on the axis, the value of normal y-axis is min 35 MPa. And this point is shear stress xy-axis point. As we see here, the value of shear stress xy-axis is 340 MPa. So now we have got the stress transformation for counterclockwise by using the Mohr circle. Now, it's your turn. Determine the equivalent state of stress if an element is oriented 30 degree counterclockwise from the position shown. Submit the answers to your lecturer. Good luck!